In this video, we begin our discussion of inferential analysis of paired data. We're going to first look at hypothesis testing on differences between paired data. The best way to explain what paired data is to use an example. Now, consider that in this scenario, in an earlier version or edition of this textbook for this class, the authors of the recommended textbook found that Amazon prices, or the prices of books on Amazon.com, were on average lower than those at the UCLA bookstore for UCLA courses in the year 2010. Well, it's been several years, and many stores have adapted to the online market. So the authors are still wondering, how is the UCLA bookstore doing today? Are they still more expensive than Amazon prices? So to answer that question, we take a sample of 201 UCLA courses, University of California, Los Angeles, and of those 201 courses, only 68 required books that can be found on Amazon. And that would make sense that we have prices from the bookstore and prices on Amazon so that we can compare for each book the prices on Amazon compared to the prices at the UCLA bookstore. So a portion of the data set from these courses has been given. For the first course, American Indian Studies, at the bookstore it cost what, $47.97. On Amazon it cost what, $47.45. And we have collected data on 68 such books. Now, our interest is to look at the distribution of prices at the bookstore and the distribution of prices on Amazon, which means that for each book, for each of the courses, we can find two data values corresponding to for each book. So these two data sets are called paired data because for each textbook, we can match or associate with each textbook two different data values which are paired values. They are paired by their connection to the same textbook. How do we conduct analysis on such data? We're going to start with hypothesis testing on the differences between paired data. Now, the first step would be to generate paired differences. That is, we'll choose in what direction we want to go. For the purpose of illustration, I'm going to take the price difference to be each price difference at the bookstore minus each price difference on Amazon. And that's what I'm doing here. So I have price difference at the bookstore minus price difference on Amazon. And I will get the price difference for each. So at the end of the day, I will end up with how many differences? There will be the number of differences will be 68 differences in values. Well, this price difference comes from these two. Once I get the price difference for this paired data, the next step will be to focus my analysis on this paired data. In other words, the data values in purple on my screen will be my new concern when I'm dealing with paired data. I will like to look at the histogram, and from the histogram, I can tell that there appears to be no significant departure from the histogram of all the differences. And the next step would be to compute the average of all of these differences. When this was computed, according to our example, we got 3.58 for the 68 differences, and the standard deviation of all the computed differences was 13.42. Based on this, we're going to set up the null and the alternative hypothesis. The null hypothesis is always the hypothesis of no difference. So, appropriately then, The null hypothesis would be the hypothesis that there is no difference or no significant difference in the prices on Amazon and at the bookstore, versus the alternative that there is a difference. If we do not want to write too many words, when we're dealing with paired differences, we say that the mean difference is nothing, no price difference, versus the mean difference is not nothing. That means it is something. Once the null and the alternative hypothesis have been set, the next step is to do the model check, where we look at independence and we look at normality of the distribution of the observed differences. Independence is guaranteed by choosing observations using a simple random sample, and for normality, as long as the differences don't have an extremely large value or an extremely low value away from the cluster of most of the data values, we can say that the assumption of normality is reasonable. With that said, we would now proceed to find the point estimate of the differences. The point estimate of the differences is simply the sample mean or the average of all the differences we observed. So if we take the average of all of the price differences, we were given that as 3.58. That is the point estimate. Now that we have the point estimate, the next thing will be to find the standard error of the point estimate. That requires to find the standard deviation of all the differences. That is 13.42 from the given values, and divided by the number of differences, which is 68. So that will be divided by the square root of 68. And that will give us 1.63. Unfortunately, we cannot do this in StatCrunch unless we have the raw data values, which we do not have access to in this case. So we're working based on the summary statistics. Once you have the standard error, you would use these two values, the point estimate right here, and that would be 3.58 minus the null value. The null value is the value in the null hypothesis, which is 0. So minus what? 0 divided by the value for the standard error, which is 1.63. So 1.63, and that gives us about 2.20. With that said, the next step will be to compute the p-value based on the t-distribution. Well, if we're using the t-distribution, then we need the degrees of freedom. That will be the number of differences, which is 68, minus 1, and that will be 67. So we're working with the t-distribution with 67 degrees of freedom, and our interest is to look back at the alternative hypothesis. This is saying mu is not equal to 0, which means it could be greater than 0, one tail, or less than 0, another tail. So we have a two-tailed test. So one tail here, and then the other tail right here. And what is the cutoff value right here? That is the value of the test statistic. So this is 2.0 right here, and there's negative 2.20 here. And we're interested in the size of the tails, which is our p-value. So our p-value is the combined size of these two tails. Well, to do that, we'll need to go to StatCrunch. So let's compute that from StatCrunch. Now, in StatCrunch, we'll need to go to Statistics, go to Calculators, go to the t-distribution. The degree of freedom here is 68 minus 1, which is 67. So, and then I would like a case of between. So I still have my between there. So I would like to look at, in particular, if I look at the area between negative 2.20 and positive 2.20 and compute that probability, I have 0.9687. That is the area in between. So if I want the two extreme tails, total probability is always equal to 1. So 1 minus the total area in between, that will give me the p-value I want. Another way to do this is to say that I can go back to the standard version, look at the size of the tail above what? 2.20 and compute that probability. That will give me the size of one tail. If I multiply it by 2, due to the symmetry of the t-distribution, I will get the combined probability. So that would be p-value here equals 2 times 0.01563. Okay, and that would be equal to 0.03126 approximately. With that p-value, which is 0.03126, and against alpha, you will notice that the p-value here is less than what? Alpha. And when the p-value is less than alpha, what decision do we take? We reject the null hypothesis. And if we are rejecting the null hypothesis, let's go back. It means we are rejecting the null hypothesis in favor of the alternative, which means that there is a difference in average textbook prices across platforms. In other words, we conclude that we have sufficient or strong evidence in support of the alternative, which means that the sample data provides convincing evidence in support of the alternative hypothesis that there is a statistically significant difference in average prices. Okay, then let us see another way we could have answered the problem, which we just answered using hypothesis testing. Another way to do that is using the method of confidence interval estimation. This is very similar to what we've just done, except that we're following a different route, but it should help us arrive at a similar answer. So if we're told to create a 95% confidence interval for the average price difference between books at the UCLA bookstore and the books on Amazon, the unknown parameter that we want to construct a confidence interval for is the average price difference. And that is our mean difference here, which we do not have an idea what it is. And so that is the population average difference in prices across platforms. The next step would be to do the model check. And the model check will have the same model conditions that we checked earlier here when we're conducting a hypothesis test. Well, with that said, then we go on to the mechanics. And for the mechanics, we are ready to do the computation of the 95% confidence interval. In general, the formula for constructing a confidence interval based on the t-distribution is given by this. In other words, we need the point estimate plus or minus the critical value at 95% confidence level, and then standard error. All right, so how do we find the point estimate? That's our X bar difference. So X bar difference is also written as D bar if you want. And according to the question, we were given the average of all the differences. That was 3.58. So let's bring that value down. So you have 3.58 plus or minus. Then you have the critical value at 95% confidence interval. So let's see. We'll use the t-distribution, which means we need our degree of freedom. That is 67 for 95%. So I'm going to go back to StatCrunch. And in this case, I would hit between because I want a 95% range or confidence interval at 67. This time, I will need to alter the last value here to be 95% or 0.95 and compute this value right here is the critical value. So it cuts off the middle 95% of what? Values of the t random variable at 67 degrees of freedom. And based on that, we're good to go back to this standard deviation of all the differences. We got that earlier. We got 13.42 all over the square root of 68. All over the square root of 68. So this would help us get to the next value. So if you have this piece, so this is 1.996 and then 13.42 divided by the square root of 68, that will give us approximately 0.32 to 6.84. So we are 95% confident that the average difference between books at the UCLA bookstore and prices of books on Amazon, of the same books on Amazon, would lie between this range. Take note that to get the differences, what did we do? We actually said that we're looking at bookstore price minus the Amazon price. So if we're saying bookstore price first minus Amazon price, and all we have here are positive values. So bookstore price, bookstore minus Amazon price. And we're only getting positive values. It must mean that we are saying big number minus small number. That is why we can only get positive values. Take note that 0 is not in this interval. So that means that prices at the bookstore tend to be what? Higher than what? Prices on Amazon by as much as 0.32 or 32 cents to $6.84, 95% of the time. So from the results obtained above, we can say that we have strong evidence that prices on Amazon is on average less what? Expensive. Take note, it's on average less expensive. How should this conclusion affect a UCLA student's buying decisions or buying habits? Should UCLA book students always buy books on Amazon? Well, given the 95% confidence interval goes from 32 cents to $6.84, we can infer that while getting a book immediately from the bookstore can be more convenient, there's a trade-off here. Sometimes saving a few bucks if you're buying more than one book on Amazon may also be worth the wait. So this is very crucial in making decisions.